Nanorobotics is an emerging technology field creating machines, or robots whose components are at or near the scale of a nanometer. We know 1 nanometer equals 10 inverse 9 meter. More specifically, nanorobotics refers to the nanotechnology engineering discipline of designing and building nanorobots, with devices ranging in size from 0.1 to 10 micrometers and constructed of nanoscalar molecular components. The terms nanobit, nanoid, nanite, nanomachine, or nanometer have also been used to describe such devices currently under research and development. Nanomachines are largely in the research and development phase, but some primitive molecular machines in nanometers have been tested. An example is a sensor having a switch approximately 1.5 nanometers across, able to count specific molecules in the chemical sample. The first useful applications of nanomachines may be in nanomedicine. For example, biological machines could be used to identify and destroy cancer cells. Another potential application is the detection of toxic chemicals and the measurement of their concentrations in the environment. Rice University has demonstrated a single molecule car developed by a chemical process and including Buckminster fullerenes for wheels. It is actuated by controlling the environmental temperature and by positioning a scanning tunneling microscope tip. Another definition is a robot that allows precise interactions with nanoscale objects or can manipulate with nanoscale resolution. Such devices are more related to microscopy or scanning probe microscopy instead of the description of nanorobots as molecular machines. Using the microscopy definition, even a large apparatus such as an atomic force microscope can be considered a nanorobotic instrument when configured to perform nanomanipulation. For this viewpoint, macro-scale robots or micro-robots that can move with nanoscale precision can also be considered nanorobots. What is nanorobotics theory? According to Richard Feynman, it was his former graduate student and collaborator Albert Hibbs who originally suggested to him the idea of a medical use for Feynman's theoretical micro-machines, see biological machine. Hibbs suggested that certain repair machines might one day be reduced in size to the point that it would, in theory, be possible to swallow the surgeon. The idea was incorporated into Feynman's 1959 essay There's Plenty of Room at the Bottom. Since nanorobots would be microscopic in size, it would probably be necessary for very large numbers of them to work together to perform microscopic and macroscopic tasks. These nanorobot swarms, both those unable to replicate and those able to replicate unconstrained in the natural environment, are found in many science fiction stories, such as the Borg nanoprobes in Star Trek and the Outer Limits episode The New Breed. Some proponents of nanorobotics, in reaction to the Grey Goo scenarios that they earlier helped to propagate, hold the view that nanorobots able to replicate outside of a restricted factory environment do not form a necessary part of a purported productive nanotechnology, and that the process of self-replication, were it ever to be developed, could be made inherently safe. They further assert that their current plans for developing and using molecular manufacturing do not in fact include free-foraging replicators. A detailed theoretical discussion of nanorobotics, including specific design issues such as sensing, power communication, navigation, manipulation, locomotion, and on-board computation, has been presented in the medical context of nanomedicine by Robert Freitas. Some of these discussions remain at the level of unbuildable generality and do not approach the level of detailed engineering.